I have the pleasure to introduce you to Norbert Hanigovszki, old colleague. He's working at Danfoss in Denmark. He's the expert we are often referring to when we talk about variable frequency drives. I know Norbert because we work in the same IEC committee. Norbert Hanigovszki from Danfoss, we have the pleasure to have you here. I would like to ask you some questions. Please tell us a little bit, what is Danfoss doing?
Yeah, Konrad, thank you very much. It's a pleasure to be here. Danfoss is a company about doing more with less. We are a big company. We have more than 25,000 employees. We have 4 business segments. We deal with heating, which most of the people know from the radiator thermostats. We have to do with cooling, which is also our biggest division. The cooling products are a bit hidden, but you go to a supermarket, you see all the refrigerators. Behind most of them is Danfoss technology. Then we have Danfoss Power Solutions, which has to do with hydraulics and electro-hydraulics. And we have Danfoss Drives, and I come from Danfoss Drives.
Danfoss is the biggest manufacturer of converters worldwide, is that true?
That is our ambition, but that is not true yet. We are on the podium. Recent studies have shown that we are number 2, but it all depends how you measure big drives, smaller drives. But we are certainly a drive manufacturer that's on the podium.
And you talk about Siemens and ABB being
Yes.
with you on the podium.
Yes.
That means you build the global converter or variable frequency drive market.
Yes.
Good. Now, why don't you explain, or try to explain very shortly, the age 20 years ago when we had normally fixed speed motors, and now the world is changing to having many more variable speed motors. What does that mean?
I think that is an opportunity, but we had an opportunity now in the last 20 years to go from fixed speed to variable speed, to get some advantages by doing this. Adjusting the speed gives opportunities in energy saving. But think about these 20 years, the drive was a power processor. We live very interesting times. We live times where the drive will be seen as a sensor tool. So it will not only process power, but also process information. And I think we are facing a new revolution, like we faced 20 years ago with the advent of variable speed. And it's a very interesting time to live in.
Very interesting. Let's talk about today. If I have an industry with thousands of motors and they have a program just to equip all the motors they have with a variable frequency drive, are they doing the right thing?
Yes.
All of them?
Yes.
Aren't there any applications where you'd rather have a fixed speed motor?
You see, we had a water plant in Denmark, in Aarhus. They are processing wastewater. And they wanted to improve the efficiency of their plant. And they put drives on all their motors, no matter what. They didn't ask the question, does it make sense or not? So
you like that, because you sold a lot of machines.
I like that. I like that. But what happened, because of changing the processes, the production process in this plant, the wastewater plant became from an energy user an energy supplier. So they are able to adjust their processes by the variable speed drive in the smallest detail, and they can use the waste from the wastewater, they generate biogas, and then they use that to produce energy. So this is an example where they didn't even think about this question. But then, look, I came by plane. I took escalators in the very nice Swiss main station, yes. Yeah. It's running fixed speed. Mm-hmm. What do you think? Does the escalator have a drive?
Should have.
It has. It has a drive. Because the drive It's not only about changing the speed, but it's also about controlling the motor, controlling the voltage we supply to the motor. And when the escalator is not loaded, the voltage is reduced, the losses in the motor are reduced, and you can gain efficiency also in speed, in fixed speed applications.
But now, we don't have any audience. Let's just talk among us.
Yeah.
Does using a converter, a variable frequency drive, not only have advantages, but sometimes also disadvantages? It costs, it has extra losses, it has part load losses, it has harmonics. No problem anymore.
Konrad, it's fantastic. It has disadvantages. I wrote my PhD on these disadvantages of drives, and which were called secondary effects of drives. But that's everywhere we look, everything we get, there are positive and negative aspects. So we need to find a balance between things. Do the advantages weigh more than the disadvantages, or the other way around?
Mm. Now we talk about new motor technologies. We started to jump from the induction motor, asynchronous, going to permanent magnet to synchronous reluctance. What's the role of a variable frequency drive when we go to the new technology motors, the permanent magnet and the synchronous reluctance?
Yes, the new motor technologies, they cannot be used without the drives. And the drives are the drives are enabled to use these new technologies. So it's very important. And we get constantly requests for newer motor types, different motor technologies, and we need to do our best to develop control algorithms.
And you say they're enablers, they're used to start up the machines, like in a permanent magnet, or also they are needed for the continuous operation?
Also for the continuous operation.
That means your business must be booming.
Yeah, you see, unfortunately, these very high efficiency modern motors are such a little part of the market. The biggest market share is still the induction motor, and will probably be so many years from now on. But we see these new motor types are emerging, and on that part, yes, we see a growth, but it's not very big.
Okay. Thank you. Then let's work together that we have a larger share of high efficient motors and systems and drives around the globe. Thank you, Norbert. It was a pleasure to talk to you.
Thank you, Konrad.